build to get the value of x to make this work. So we know that the 29 is playing the role of the longest side length. So we just write it out. We have x plus 2 squared plus x plus 3 squared is 29 squared. And now go step by step with this. So if you haven't done this or you didn't write down the right problems to do this, write this down. It might be helpful. It's what? Okay. So that means we want that side to be smaller. From there, then, we go ahead and FOIL stuff out. Now, when you FOIL stuff out, don't try and do too much at once, because I've seen you guys work, and sometimes you kind of do a little more than you need to, or you get messed up in what you're trying to do. First, outside, inside, last.
Okay, do that one. I don't want the outside, inside, last.
Multiply your first terms together. So what I'm doing here is I multiply your first terms together. I multiply the outside terms together, the inside terms together, and then the last terms together. I get x squared plus 2x plus 2x plus 4. All right with that? I do it again. First, outside, inside, last. X squared, 3x, 3x, and 9. Now, is everybody okay that eventually I'm going to have to subtract over that 29 squared? So I'm just going to write down minus 29 squared greater than 0. Okay? Can you put away your phone, please? Thank you. All I did was FOIL. FOIL twice. Number 20. Okay? Now combine your like terms. X squared and x squared is 2x squared. 2x and 2x is 4x. 3x and 3x is 6. 10x. 4 and 9 is 13. Subtract the 29 squared. And I think, is this the one you get negative 414 when you multiply that out? I'm seeing heads bob, yes, so that's it.
Yeah.
All right. So, now you're at a quadratic. You can choose to do one of two things. At this point in time, you can go ahead and use your quadratic formula with your a's, b's, and c's at 2, 10, and negative 4, 14. Use the calculator. It's going to be just fine. Or if you recognize that you've got all even coefficients, you can factor out a 2. The only difference it does there, it just makes the number smaller. That's it. It's going to simplify itself in the long run, so it's not a big deal if you go either way. Personally, whenever I see GCFs, I take the GCFs out. It's just habit, and it makes life easier. Especially, a lot of times, sometimes you won't have that 414. It might be something easier like 6. If you factor out a 2, you get 3. You could probably work with that a little bit cleaner. So if I take out a 2, since you're solving for zeros, it doesn't matter. The 2 has no bearing upon it. It's like a scalar. It's just an extra multiplier. So you have x squared, 5x, and what is that? 207?
Yeah.
Yeah, but I thought it equals 414, doesn't it?
It's 25.
Oh, that's right. I knew there was a 414 around there somewhere. So this is an 828, and then divided by 2, it's the... Yeah, thank you, because I was going, wait, that's not going to work now, because that's not what I was doing earlier. I got ahead of myself. I knew there was a 414 at some point. In about 6 hours. So that's greater than 0. Wait. Could you go back? Thanks. So at this point, what I would do, and this is a huge suggestion for whenever you're using quadratic formula, and then next year when you get to Algebra 2, there's a lot of times that you're going to be using coefficients of polynomials, whether they're quadratic or not, that you're going to want to know what they are. Because if you list out what your values of A, B's, and C's, and eventually we'll look at H's and K's and things like that, you're going to be able to plot stuff through. Stop watching the stuff on your phone. Oh, I thought you were hiding it.
No.
You had that look.
I was confused.
You have that look too. Now at this point here, I'm just going to write it out. A is 1, B is 5, C is -4, 14. Also, by rewriting that down, it reinforces where things are going to go within the quadratic formula. Speak of the devil. Now you have it all written in front of you. It's a matter of substituting in the actual values. Okay? As I start to fill in the values, I know that, well, B is 5, so what's the opposite of 5? -5. Can I scroll this up a little bit? So I have, my zeros are going to be at -5, plus or minus the square root. 5 squared minus 4 times 1 times -4, 14, all over 2 times 1. Now it looks like a lot of math. You cannot put that directly in your calculator like that because there is no such thing as a plus minus button on your calculator. So what you need to do is type in what's underneath the radical first. That b squared minus 4ac, if you recall from last year, is called the discriminant. The discriminant has a bunch of different things that it tells you what it can do. For our purpose, it doesn't really matter what it's doing, but next year again in Algebra 2, it'll help you decide whether or not you'll have real zeros, imaginary zeros, or just 1 0. It'll be able to give you that kind of clue rather quickly. So you just type in the calculator what's underneath there, just like this. So if I type in 5 squared minus 4 parentheses 1 parentheses parentheses -4, 14. If I type it in exactly like that, well, it'll give me.
See, mine didn't do that.
This would be a minus.
Oh,
That's for minus.
okay.
That's fine. Okay. And that's what's great. That's the other cool thing about these calculators is that I can hit the arrow up button and figure out what you screwed up. So by the way, if you have not yet purchased the multi-view calculator, please get one soon. You will so very need it, especially come Monday when we do special right triangles.
Has anyone passed without it?
No,
Really?
it's very difficult too. Yes, sir. I mean, you can. You just have to rationalize everything by hand. It's a big pain. Okay, you
Right.
got to have it. So now I have to find the square root of that. To be quick, second root of my answer, we have 41. Okay. So I know that it's my answer then winds up being -5 plus or minus 41 all over 2. But this means that there's 2 possible solutions for x. One of them is -5 plus 41, take half of it, or -5 minus 41 and take half of it. Before I go further, I want you guys to think of this for a second. We're trying to find a value of x. That value of x gets resubstituted into something that has a side length. If I take -5 and -41, I get -46, right? half of negative 46 is negative 23. Is that going to work for my x value? No, because I'll still have negative side lengths. Okay. So I know that this one isn't going to help me any. But this one will. What's negative 5 and 41?
36.
What's half of it?
6.
That's square root. What's,
8. I just said.
Wait, what?
I'm
so
36.
not 26.
Okay, don't look at it like, yeah, that's not. Everyone loses up, right? We have a degree.
Yes. They take forever to go through some of these problems. They really do. There is no real shortcut for this, unfortunately. The shortcut for this will come at a final, because finals are multiple choice. If you had specific answers, couldn't you just plug and chug to see which one's going to work with the Pythagorean theorem? Yes, sir. What's the coefficient in front of this? 1. If you don't see anything there, if it's just x squared over x, it's always implied that it's a 1 in front of it. We just don't write it down, because we like to say it. Right. Well, no, not the 1 squared. The value, the x is what's squared. The coefficient's just the one out in front of it. That's all. Because here it was 2. We took half. We just cut it all out. Yep. Yep. That's very common. All right. And then later on next year, you guys will do stuff with coefficients as well. Let's say it's 5x to the third plus 2x plus 1. When you use something called synthetic division, something you'll do next year, see how this is written in descending order? The degrees go from 3 to nothing to 1 to nothing. What x term is missing? If it's a third degree polynomial, you should have 4 parts to it: a cube, a square, a linear, and a constant. It's missing an x squared. Do you agree? Which basically means this is the same thing as saying because what's 0 times anything? 0. So we do that a lot. We keep things out. And these are equivalent statements, but this just wastes precious ink. Ever so precious ink. Same deal with putting a 1 in front of an x. You don't need it. Okay? But you'll do a lot of that again next year. It doesn't show up that much, but I figured I'd just show you what it kind of would get into. Okay. Does that clear up some of the confusion with, yes, it's a pain in the butt, I'm not going to lie. It's a giant angle side of a time.
But if you really.
It's like you guys oh. It took you a while.
Are we okay other than that one? Will we be able to finish the other ones out?
Yeah.
All right, let's add on to this real quick. I want to do another example with you, but you need to have graph paper. There's a couple more styles of problems on here.
Why?
Anything else on that?
Yeah.
Take a sheet of graph paper, and I want to show you guys another thing that we do with the quadratic stuff.
I'm on TV.
So another thing that we do, I'll let it come up first. What's that? No, because the other problems that are like this on that sheet, we're just finishing it out for Monday. Yeah. So let's say you have ordered pairs. What do I have on my notes here? I have 8, 4. Is this for the first one?
Yeah.
Yeah, just one of those. What I'm looking at here, guys, is that I want to talk about, just like we did yesterday, we were able to determine what type of triangle was created via their side lengths. Well, what we can do here, given sets of ordered pairs, is figure out the side lengths of a triangle without using distance formula. What we're going to do is just use Pythagorean theorem a few times. And it's a matter of creating right triangles just by counting the boxes. Okay? So if I have 3 points, I have -8, -4, -5, -2, -1, -7. First thing I need to ask you guys is, which one in the ordered pair is the value for x, the first or the second? The first. Therefore, the second is the y values. Now, you have 2 axes, up and down, left and right. Which one is the left and right? Yes. X's go left and right, the y's go up and down. Okay? So, let's look at this. Let's plot -8, -4. Go up -8 and go down -4.
That was right.
Five.
Go up.
All right, there's your first one. Do it again. -5, -2.
It's like a triangle.
Gee, it's got 3 points. What do you think it's going to create?
A triangle. A triangle.
So we get a triangle. Now what we can do is we can decipher what this, yeah, blah, blah, blah. I don't say blah, blah, blah. What is it? Hotel Transylvania? My kids love that movie. I do not say blah, blah, blah. All right, so at this point now, all you have to be able to do is count. Can you count?
Yes, sir.
Yes.
Are you sure? All right, ready? 1, little 2. I went up 2. Let's go to the right. 1, little 2, little 3. So what I've done is I've gone up 2, right 3. Notice vertical and horizontal create a right angle, which means it becomes a hypotenuse. So what is 2 squared plus 3 squared?
14 squared.
Is how much? You get 13. Now this is just 13, but in order that would equal the c squared side. So what would c be equal to? The
Whatever you
square
want.
root of 13. Okay. So now what we do is just this. We're not going to simplify the square roots for any of these because I'll show you in a second why. Just write down root 13 for that spot there. And we're going to do the same thing for all 3 sides. Here we go over 1, little 2, little 3 little spots, 4.
It's such like a class that you just ruined.
And then we go down
5.
1, little 2, little 3 little spots, 4, little 5.
It's so unsatisfying because you have to do. I know.
In your heads, you can finish the song. So now I have a triangle with side lengths of 4 and 5. They're right triangles, so I have 4 squared and a 5 squared. Well, that's 16 and 25 is. So that means that side length would be root 41. And then I work my way back. 1, little 2, little 3 little spots, 4, little 5, little 6 little spots, 7. And then I go up. 1, little 2, little 3. So I have a 7 squared and a 3 squared. 49 and 9, 58. So that's how it would equal the square root of 58. So now I'm looking at those 3 side lengths to determine what type of triangle it is. Gee, isn't that the exact same thing you did yesterday on those first 6 problems? All you had to do was figure out the lengths. So now if I do that, which of those 3, since I left it in that radical form, which of those 3 has to be the biggest? 58. The 58. So that has to be the hypotenuse. So the square root of 58 squared, what's the relationship between that and root 13 squared and plus root 41 squared?
Oh.
And this is why I talk about what's the square root of junk squared. What's the square root of junk squared? No, junk. because it undoes itself. The square root of 58 squared is 58.
So it's really the same thing.
Yes, sir. And then what's 13 plus 41? So is it that longest side length, is it equal, greater than, or less than? Which means what kind of triangle is it? Obtuse.
Okay.
So what you're doing here is you're just counting to get the side lengths, leaving it in radical form, because I know your calculators will simplify them out, but that's the main reason why I'm just leaving it as 58, leaving it as a square root. Yes, sir?
So you add those two for one.
Yes, sir. Because we're using Pythagorean theorem to determine is that bigger side equal or greater or smaller than, just exactly like you did yesterday. The only thing that's different is that I'm adding the steps of having to use, is that enough?
Yes.
All I'm asking you guys to be able to do now is just add in those couple extra steps of Pythagorean theorem. So you're looking at these problems now, you're using Pythagorean theorem 4 times. That's it. Okay? Let's try another one. Can I go to another one? I'll give her a second.
Mr. Murphy, do
Yes, sir.
you know how to crack someone's back?
Yes, sir.
You do?
Yeah, but I'm not cracking your back.
Okay.
Why don't you just have some, step.
Or you
actually
just
break your
stretch
mom's
back in your chair.
Lay your back on the floor. Lay it flat on the floor. Pull your knees up and twist. Yeah? All right.
What do you mean twist? Twist. Here. Yeah.
It's funnier to watch him do stuff.
You don't even need it cracked.
It's so do it to me, do it to me.
I take no responsibility for any of this. I'm just gonna sit here and try to act cool. It's a difficult thing. All right, I got 3 ordered pairs. We got -2 and 4, 6 and 0, -5, -2. Let's do the exact same thing. We'll do the exact same thing. Holding.
Thank you. Hold.
Oh, it's just funny. Thank you. All right, let's plot them. -2 and 4. -2, 4.
One goes to -2.
6 and 0. -5, -2.
We need a ruler.
No, you can just rough sketch. It doesn't have to be perfect. I mean, if you want to, it doesn't matter. Because even if you have a ruler, it doesn't show whether or not it could kind of show that it looked like a right triangle. I mean, the last one we did look like a right triangle, but we showed that it wasn't.
Yeah.
Okay? So, again, all we need to do at this point is just walk the graph and use Pythagorean theorem. So pick a spot to start with. It doesn't matter which one. I might as well just start here. Ready? 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots. Yeah, all right, we'll do that. So this was 6. 1 little, 2 little, 3.
No, 3 you gotta finish it.
It's 3 little spots, 6 little spots.
I could see 7
So-
spots too.
6 squared plus 3 squared, 45. Now, we know that it's going to equal 45 would be equal to that side squared, so I'm just going to leave it as the square root of 45, okay? Your calculator, if you hit the square root of 45, it'll spit out 3 root 5. But later on, if we go to compare our side lengths, it's more difficult to compare the side lengths if you have the radicals fully simplified. Does that make sense? You'd have to look at your decimal equivalencies. By leaving it in radical form, just unsimplified radical form, for this style, it's easier to recognize what's going on. Do it again. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8, total spots.
There you go. 8 total spots. That works.
I'm improvising.
But it works.
But there's more than 8 total spots.
But the droning at the end is perfect.
What? You didn't sing it.
1 little, 2 little, 3 little spots, 4.
Thank you.
You're welcome. 8 squared and a 4 squared. So what is it? 64 and 16 is 80? Leave it as square root of 80. Again, your calculator will spit something out for that. You don't need to write it out. What is that? 4 root 5?
What?
Just not as much.
It's just gonna
Not
So we have a root 45, a root 80, and now we go again. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8 little, 9 little spots, 10, oh, I need to go 11 spots. What's up?
I need 1 little 2.
1 little 2.
Knew it.
So
Wait,
anticlimactic.
it's 11, or I thought it was 10.
11. Ready? Count again. 1 little, 2 little, 3 little spots, 4 little, 5 little, 6 little spots, 7 little, 8 little, 9 little spots, 10, I gotta add another spot.
Now I got it. When I thought I had my answer, but I didn't.
Also, if you didn't recognize yet, we're making a rectangle.
It's a
Whoa!
triangle.
No.
So we have 11 squared and a 2 squared. It's gonna give me $1.25. You could probably look at this right now. We're looking at these 3 values. The square root of 45 squared is 45. The square root of 80 squared is 45, and 80 is?
125.
It is a
Right triangle. I changed my answer.
Yeah. Wow.
do those 6 on your sheet. I will suggest the 6 that have the graphs on that sheet, don't graph them on the sheet. Excuse me. Graph them on the on the graph paper I gave you. The graph paper on the sheet goes by different scales, and it's difficult to count. Okay? It's difficult to count. Yes, sir.
I never got 72.
Oh, okay. I'll get you one. Anybody else need one? I thought it was here yesterday, right?
Yeah, I drove here. I don't know if
All right. So, guys, I want you to do those.
I knew.
Yes, ma'am. Make sure what I want you guys to do are those 6 graphs then, but do it via the counting like we just did. Do it just like that, but do it on the graph paper I gave you. Because if you look at the graph paper here, the very first problem, number 7, you're counting by 2s. That's a pain in the butt. Don't mess with scales if you don't need to. I gave you guys 10 by 10 graph paper, and it should work really cleanly. Okay?
Wait, so just keep doing what we're doing?
Yes, sir.
So go back at 10.
Yeah. Yes, 'cause you can do 7 through 12. All we were doing is rotating when you plot them. It's basically kind of different. So you this is squared, so 3 squared, so 2 squared plus 3 squared. Mr. Murphy, so this how it is squared.
Trump's officially sworn in as the 45th president of the United States.
How you use the calculator to figure out whether bigger or smaller.
Alright, and so
Yes, sir. Yep. Oh. What's up? Who's yelling at me? Good. Picked up my small child and twisted my back wrong this morning.
Oh.
He's not a very small child.
7.
What's that?
He said,